of a research initiative. I am Megha Sapkota, present here on behalf of GIFSA CRAFTS, a student-driven research initiative of Government Institute of Forensic Science, Aurangabad. The vision of this research hub is to harness the power of mind driven by research, innovation, creativity, and critical thinking for smart and reliable forensic solutions. And to accomplish these visions, missions are number one, to inculcate the innovation research processes based on creative and critical thinking. Number two, to explore the new avenues of research in forensics by ideating, prototyping, and testing. Number three, to collaborate with various organizations for innovative solutions related to forensic problems. Presently, we have four wings in our research hub, namely event management that will be looking after organizing of different events. Next wing is publication that will be looking after publication of news, letters, articles, etc. We have another wing called as research linkage that will be engaged in research collaboration with different organizations. Again, we have IT management wing that will be with us with IT support and will handle social media platform. The initiative has been taken to promote research culture for betterment of the society. And so today, to add up to our research knowledge, we have with us Mr. Roshan Paladugu, sir. Sir has done his graduation in forensic science and he is a Marie Curie fellow and early stage research fellow at University of Avora, Portuguese, within the framework of European Union funded project ED-ARCMET, that is European Joint Doctorate on Archaeological and Cultural Heritage Material Science. Sir primarily works over the stable isotope analysis on archaeological and archaeobotanical remains to reconstruct agricultural strategies of past societies. I welcome you, sir, to this amazing session. Over to you, sir.
Thank you, Megha, for that very pleasant introduction.
Welcome, sir.
So I'm going to just share my screen now for the PPT.
Yes, sir.
Okay, so I'll try to keep my presentation a bit informal in the sense of the content which I wanted to deliver today, because I've had this conversation with Professor Rajesh Kumar, and when he came to interact with me to present some of my ideas and my experiences throughout my journey from my undergrad till this doctoral position, he wanted me to share some of my experiences and some of the lessons which I've learned throughout my journey, so that it might be useful for the students who are currently pursuing forensic sciences in India. So I'll keep it less technical and more of an insight-based content. So we'll be looking at some case studies and something called an outlook, and we will see what I mean by outlook in this specific context. So what are pure sciences? Pure sciences are a branch of sciences which are concerned with the discovery of natural phenomenon and which tries to explain the associated laws with that phenomenon, why that phenomenon is occurring, how that phenomenon is occurring, and nothing else. It's more of a very ascetic approach to understanding the way the universe functions. And usually it does not concern itself with how it can be exploited or utilized. That's where applied science steps in and deals with the application of these laws and the phenomenon which have been discovered and explained by the pure sciences. And applied sciences mainly concerns itself with applying the laws to control this phenomenon to improve human lives or for profit in the case of industries, or in some cases both improvement and profit. But this is not the end of the scientific journey, let's say. When you focus more on problem solving, because usually translation of the scientific laws into practice often involves technical issues which occur at every stage, and you need a completely different approach than from pure science or applied science to translate into actual usable products. And this is where technology steps in. And this is an intermediate level of science, let's say, in quotes. So it's not exactly science, this is engineering we are talking about, which is a very, very problem solving approach to go from theory into practice. So let's take an example. We know about internal combustion, which is applied science, and just combustion is pure science. But to go from combustion to internal combustion to actually driving a car, you actually need a lot of different specialized engineers to build you that product, because they concern themselves more with solving the technical problems. So when we have defined or categorized our sciences into roughly three categories, let's talk a bit more about some of these words which we keep hearing in forensic science again and again and again, which is multidisciplinary, interdisciplinary. And the word transdisciplinary might be a bit new to people in India because it has still not arrived in India at the moment, and not even in the world. It's a quite relatively new term which people are using. So multidisciplinary is a word I'm sure a lot of you guys here, attending this talk might have heard from research papers or from your professors. So what does multidisciplinary mean? Multidisciplinary means the individual learns concepts and skills separately in each discipline, but in reference to an underlying theme. So you study physics, you study biology, you have different professors teaching them to you, but you have an underlying theme, which is forensics, because you study these fields not for the sake of researching in those fields, but to take away key facts and key processes, which you can later repurpose to be used in a forensic context, in a judicial context, let's say. So in the diagram above, you can see intradisciplinary is just you being inside one discipline. Like you're a biologist, you're a chemist, you're a physicist. But then in forensic science, by the very nature of the field, you're multidisciplinary at least, because you take facts and processes from different disciplines and put it together in order to facilitate criminal justice system or in any other context required. Then you have something called cross-disciplinary, which is an advanced form of multidisciplinary where there is greater integration of these disciplines, where these disciplines are already aware that this individual is actually cross-linking different research topics or ideas from each other's discipline. Then you actually move on to the next stage, which is interdisciplinary, where there is significant overlap of all these ideas. So you actually learn the concepts and skills from these disciplines, and then you integrate them to actually develop knowledge and skills which become highly specific to the problems you're solving. And this is where currently I believe forensic sciences in India are trying to move to, but have not actually arrived to that point. And let's now talk a bit about transdisciplinary. So transdisciplinary approach is a completely radical approach, and you can see it there. All the dots have gone on top of one another, and you can't actually tell which color it is because it's a mixture of all these colors, and it's a completely new color from what you've started. So you learn the knowledge and skills from two or more disciplines, and you aim at solving real world projects, which means you're more of an engineer than a scientist at this point, but not strictly in the sense of an engineer, but more of a hybrid between a scientist and an engineer, because you don't start learning facts or theories from disciplines because you want to journey in those disciplines, but you actually start with the problem. You ask yourself the question, what are the real world problems? What are the real world applications? Once you identify those problems, once you have targeted the issues you want to address, you start working in the reverse and you start making a list of all the disciplines or the tools or the facts which you need to learn in order to actually solve the problem. So you transform from a person who was learning concepts and skills separately in each discipline, even if you're not going to use them in multidisciplinary approach, to an interdisciplinary approach where there is a deeper integration of these disciplines, to a completely radical approach where you go from the, let's say, top up approach instead of a bottoms up approach, and you actually go from problem solving to learning theories which are actually useful to you, and you don't bother yourself with other stuff which is not required. So, as I've said before, forensic science in India is currently at multidisciplinary, and we cannot afford to go through interdisciplinary. Yes, this is a bit controversial. What I'm saying is, why can't we go through interdisciplinary? Because people in other countries have been doing so. They have been going from multidisciplinary to interdisciplinary, and now they are at the border of interdisciplinary and transdisciplinary. But we cannot afford to go from multidisciplinary to interdisciplinary at this point, because there's a very wide and deep gap between the kind of human resources and the infrastructural setup between us and the rest of the world. So if we move now from multidisciplinary to interdisciplinary, we will never catch up with the rest of the world and the pace at which science moves, which is very, very fast. It changes from day to day. So we need to actually make a qualitative leap from multidisciplinary to transdisciplinary. And this is very, very vital to understand why we need to make this qualitative leap, because we are already in a spatial lag in this competition of research. And if we go through something which is already outdated, we are not doing research anymore. Research needs to be new, research needs to be fresh, and research needs to be something which is very, very not anachronistic, meaning something which does not belong to this time. We cannot do that. We need to always do something which is relevant to the times we are living in. And the time we are living in, this 21st century, is a transdisciplinary century, and we need to go into problem solving. So how do we do that? Before we go to how do we do that, or what are the things we need to keep in mind, I would like to present you some case studies between how we can actually take from other fields which have already started kind of adapting this transdisciplinary approach, or fields which have something in common with forensics. And in my introduction, I've been introduced as somebody who has done his bachelor's in forensic science, but has later doing a PhD in archaeology. And people might be wondering, how is this possible? You study forensic science, then you say as a forensic scientist. So I want to clear some doubts here about how this was done. This has been done. So forensics and archaeology are not really that different in terms of their approach, because there is a central theme to both of them, which is this holy trinity of man, time, and environment, where all the three are affecting each other. The only difference between forensic science and archaeology is that archaeology concerns itself with the reconstruction of events and processes which have occurred thousands or sometimes millions of years ago, whereas forensic science only concerns itself with the events which have occurred in terms of some kind of breach of law, and in very short periods of time, usually in years, not more than that, due to the statutes of limitation. So the main difference between forensic science and archaeology is the temporal scale in which they deal with, is the time on which they are working. The man and the environment more or less stay the same in terms of investigation. So when I moved from forensic science to archaeology, I was literally doing a lateral transition from forensic science to archaeology. I always wanted to work on bones and teeth, which was what I was trying to specialize and learn more in my undergraduation. And I had managed to do to certain extent at GIFS at my time in GIFSA, with some help from the professors, I must say. And I was also very much interested in chemistry, especially the stable isotope chemistry dealing with carbon, nitrogen, and oxygen isotopes. So it was the same combination, it was the same kind of application, but in different contexts. So it was very easy for me to take this transition. And now We will look at some case studies from both archaeology and forensic science in different capacities, and I would like to draw your attention to how they are similar. At the same time, I would like you to take away some ideas at least, or what kind of thinking is needed for you to find some applications in forensic science, how you can actually look into other applied sciences and see if you can take something back into your field. So when we ask the question where, and I know that in forensic science we like to ask a lot of questions, and it's the same in archaeology. You always ask a lot of questions and you're never fully satisfied with the answers you get back from the evidence or the material. So when you ask the question where, you're actually answering provenance. And what is provenance? Provenance is the beginning or the earliest known history of something's existence. And that something can be a person, can be an object, can be a natural formation, geological formations. So in archaeology, I would like to present this interesting case of investigating the geographic origins and growing conditions of olive seeds or olive trees, because the seeds come from the trees, obviously, found in shipwrecks using stable isotopes. So you can see they had investigated in the Mediterranean region underwater actually. So they were deep sea divers going in, and they had identified some ancient Greek shipwrecks. So the ships had actually capsized in middle of the sea, and the ships were carrying some commercial products of their time. And they actually recovered intact amphora. Amphora are pots, Roman pots or Greek pots. In this case, they are Roman pots. And you can see in the picture on the right that when they actually opened the amphora, they found some organic material with a lot of seeds, and you can see the magnified view. They actually found olive pits. So there's a encasing over the actual seed, and you can see when they open it, that's how the seed looks on the inside. So the question arises is, how can we tell where these olive seeds originated from? Because it's from historical resources, maybe you can trace where they were going to, or you can guess it from where you actually found it, some kind of hypothesis. But the main question is, where do they come from? Where were these olives originating from? So how do we investigate it? It's never a straightforward road, as you might realize. Even in forensics, you can never completely do a crime reconstruction with from just one evidence. You actually look at multiple evidences, and you actually take all of them together with the circumstances, and then you eliminate all the improbabilities, and you eventually arrive at the most probable explanation to those evidences. It's the same in archaeology. So what we analyze are delta C13 values, delta N15 values, and strontium 87 to 86 ratios for local geology. So what do we understand from these isotopes? What do these isotopes actually tell us? So with delta C13, what you can actually see is how well the plants were watered, how much rainfall or how much artificial irrigation was being done around these plants, because the delta C13 values vary a lot with respect to how much you water them. And this is this is directly linked. The water status is directly linked to the delta C13 values, because plants can only take carbon from the air, from the atmosphere. And by plants, I mean terrestrial plants and not underwater plants. So their only source of carbon is CO2 in the air. And the CO2 in the air has a specific isotopic fingerprint with respect to carbon. And depending on how much water is available, these stomata constrict or open depending on the availability of the water. Because when there is less water or there are arid conditions, the stomata tend to constrict to prevent loss of water by transpiration. And this constriction causes a isotopic fractionation at the opening of the stomata, as well as the due to some enzyme inside, which we will look on the different kinds of photosynthesis. Many of you are from biology, and I'm sure you know the difference between C3, C4, and Prussian acid metabolisms. So there you can see a difference, and at the bottom right you can see there's a figure explaining how wheat, barley and lentils react differently to different watering conditions with respect to delta C13. So you can actually know what was well watered, what was moderately watered, and what was poorly watered. And how does this help us? Because we know from climatic reconstructions which regions in the world for that time period had good rainfall or were arid or had a moderate rainfall. So we can eliminate some geographical regions based on this. Then comes the delta N15. This actually helps us understand if there was, what was the nitrogen availability to the plants, and plants take nitrogen from the soil. And if there was manuring involved, or if there was no manuring, or if there was how does the local isotope geochemistry fingerprint vary? Because if we are studying some material from a period where there was no manuring involved, then the delta N15 values directly refer to the soil isotope geochemistry, and it helps us understand and further eliminate all the improbable locations. And the final nail in the coffin to solving this problem is to actually measure the strontium isotope ratios, because strontium is not at all useful for living beings. It's not one of the vital micronutrients we need. We intake it along with calcium because it's very similar to calcium in terms of its chemical properties. Um, and the thing is, there is no fractionation of strontium when we uptake it in terms of from water. And that ratios are totally dependent on the local geology. So with these three parameters, you can actually identify where a specific plant material is coming from. And with this, you could identify the olive stones from these shipwrecks. And they, in this case, they found that these olives were originating from Greece. So let's look at the forensic application of this. Like, how would you apply this kind of knowledge from archaeology to modern day? Because forensics deals with the current situation. So most of the world's olive oil comes from the European Union. That's where I'm based at the moment. And they're also one of the biggest consumers of olive oil because it's very cultural for them. And they produce around 3 million tons of olive oil every year, and 2 million tons are produced directly in the European Union. So, and mainly 5 states are involved in production of olive oil. And they're also the largest consumers, let's say more or less the same states which produce it. So European Union is very specific when it comes to food quality and food standards. And there is a concept called as protected designation of origin or indication. And you can actually see the logos on the right, on the top, with the red and the blue. So what are the protected designation of origin or protected designation of indication? So these are actually, they're like the ISI marks in India, kind of, for food specifically. So what they say is when a certain product has the protected designation of origin label, it means that all the raw materials which are required for making that product come from that specific geographic region where it's indicating. And it also guarantees that the geographical origin, the quality, and the knowledge of making the production and the manufacturing of the product actually originates from that region. And this gives the product a certain guaranteed market value because you're assuring the consumers not only the quality but also the provenance of that product. And then what is protected designation of indication? This is a slightly lower level of the label, which means at least a part of the product or the part of the knowledge or the technology originates in the geographical region which is indicated. And imitating the brand or the product is a punishable offense in many countries. And when there is actual counterfeiting of these products, it causes way more economical damage than normal products because these are products of higher value compared to the normal products which you produce. So How is it in India? Because, okay, great, European Union has this thing. So how does India deal with it? So all the products which are very famous, food products, which are famous from India, I have put them in a box. So you have Darjeeling tea, you have Sikkim tea, you have the miso chili, the fenny from Goa, the Alfonso mangoes, which are called the king of mangoes, the basmati rice, I beg your pardon, I wrote tea, and many more. So why is the Darjeeling tea in green? Is because Darjeeling tea has actually been designated as a PGI by India with the EU, and this has been registered since 2011. And because of this registration, there is a significant increase of price for Darjeeling tea in Europe, and we are given the exclusive right to sell this product inside the European Union territory. You can imagine the amount of tremendous economic benefit our country has reaped from getting a PDI label. Imagine how much we would get if we could do a PDO label on Darjeeling tea. And here is a um, bar plot from the registered GI products, geographically indicated products in EU from other countries from EU. You can see that China has 10 registered products, whereas India has just one, which is from Darjeeling tea. And I think we could work in this direction to actually get more PDIs or PDOs for more products. But what does this mean for forensic science? Because somebody needs to investigate and somebody needs to assure the quality of the label, the value this label carries in the market. And this is not archaeology, because we are not investigating Darjeeling tea from 2000 years ago. We are investigating Darjeeling tea from now. So somebody could actually work in this direction to get labels for these products and start some kind of service or some kind of organization which deals with assuring the quality to third parties or third party markets outside of India. And this is a very significant economical benefit both for the service providers as well as the farmers. And this data has been taken from the uh, Trade Commission of India, which says that geographical indications are very necessary to have a better market for India in other countries. Another case of how isotopes are used in forensics is to detect food adulteration. So in this specific case, I would like to present adulteration of grape juice with cane sugar to improve sweetness or sugar content. And in this context, when I mean grape juice, the grape juice, which is a raw product to produce wine. So wine is another important commodity in Europe after olive oil. We don't have this kind of legislation in India because we are not a majority wine consumers, and we also don't consider this adulteration. But in Europe, this is a very, very serious offense. So the most common type of wine adulteration is the addition of cheaper products to original wine, such as fruit juices, water, and sweeteners, which are not related to grapes or the fermentation process. So the European Union actually has a regulation, which is 607-2009, which regulates the origin and the labeling of wine. So the question now arises is, how can we use isotope fingerprinting to understand if somebody has added sugar to the grapes? Because the European Union expects that all the sugar which is present in the wine comes naturally from the grapes, and this is completely dependent on the climatic conditions of that year. So you might have an year where the weather was bad and the sugars and the grapes have not developed enough amount of sugars. So sugarcane is a C4 plant, whereas grapes are C3 plants. And you can see that the delta C13 values of the C4 plants are more positive compared to the C3 plants. So when you expect a pure C3 isotopic signature from the wine, because they are being produced from grapes, and you see that they are not that negative and they are way more positive than what can be allowed for C3 plants, you know that some kind of adulteration has occurred. This is just one application I have showed you for the legislation from Europe. India too has a Food Safety Act, and it too has a lot of provisions We do have food inspectors, but you can also think in this area because a third party quality assurance is always better. And if you're certified enough, this is also well considered by markets outside. And what about the provenance of objects? So here there's an overlap of objects from archaeology or heritage sciences into forensic science. So objects of cultural heritage are a source of great controversy because usually these might be stolen. Also because of a colonial past, many of the objects of heritage from many of the colonies are now in Europe in their museums. And this is a source of also political debate about where the object should belong to. And you might have read in the newspapers that 2000-year-old bronze Shiva statues from mainly South India have been smuggled to Australia, to the US, to England. And there is a huge project which is called the India Pride Project, which is trying to repatriate these statues from abroad back to Indian museums or sometimes temples, because these statues are also stolen from temples. For example, the state of Tamil Nadu has a special legal statutes which deal with only stealing from temples, these bronze statues, and it's a very highly punishable offense of 14 years of rigorous imprisonment. But this has not deterred criminals from stealing them. But unfortunately, the India Pride project only deals with repatriating statues or artifacts which are holy for the Hindus, and they are not yet put their efforts towards other cultural heritage of India, which is abroad, because there are way more artifacts of Indian heritage lying in museums abroad. But how can forensics help here? What can forensics deal with it? Because it's a statue, it's a sculpture. How do we know it belongs to India? Of course, from the stylistics, from the way it's made, they are very culture specific. But we are sciences. We want to have more information. We want to be more scientific in terms of natural sciences. So what happens when you establish the provenance of a statue is first thing, if it's authentic, because there are cheap imitations, there are forgeries, and they are sometimes sold on markets to steal money from innocent people, because not all cultural heritage objects are questioned on their ownership. Some of them are privately owned. So if you can establish the provenance of the object, it increases the claim of the object's authenticity, and the establishment of its origin with respect to an artist or a culture provides very strong evidence for its authenticity. And when you auction them, the price usually increases by a substantial amount. So forensic sciences services for maybe auctioning houses, museums, private dealers, this can be the kind of thing you might want to look into. Also for valuation, as I have mentioned, if you can reproduce a complete chain of custody, as we like to call it in forensic science, of an object in its history, it has a positive impact in increasing its market value. And for the ownership, of course, because many times these are stolen, these are illegally smuggled from countries. So it's very important that we establish the ownership. And how can we establish an ownership? With isotopes, uh, with document analysis to see if everything is authentic, if everything is in place, if there is something out of place, shady, to look into these tiny details which non-specialists cannot identify, something which is very, very apparent to people from forensic sciences. Okay, enough of where, enough of provenance. Now the question arises, what? How do we characterize it? What's characterization of material? So the characterization of anything is a description of the distinctive nature or features of an entity. And this is something which both people from forensic science and archaeology love, is to know what it is. Because usually when you find it, they are in a shape or form which does not make it very easy to identify. And often when it's unknown, it's infinite possibilities. So I wanted to present something very simple and very straightforward in the case of what. So in archaeology, you have these beautiful paintings, murals, mosaics, and the artists, both the modern ones and the ancient ones, loved to use a wide variety of pigments which changed from culture to culture and also with time periods, because with the advancement of time, the technology and the science of making colors also improved. So you can see the changing of colors and pigments in the artist's palettes along with time. So how do you identify them? When you see a new painting or a mural or a fresco for the first time, is you use different kinds of analytical instruments, both portable and benchtop, to analyze using mainly spectroscopy in many of the cases, or you can also use in some cases XRD, which is diffraction based phenomenon, and identify. So in this case, they were using Raman spectroscopy, something which we do have at GIFSA in the physics facility, if I'm not wrong, and they have identified red pigment in the fresco, which is red ochre, and red ochre is actually iron oxide. It's a kind of iron oxide. And they've also discovered that there is gypsum, which is actually pretty much common in frescoes. It's used as an underlayer. And in this way, you can identify uh, pigments and compounds and characterize materials of the unknown using databases, and if you're good enough, just by looking at the spectrum. What do we do in forensics? Pretty much straightforward, and I'm sure many of you have guessed by now, if you've already done this practical at GIFSA, is to identify vehicular paint in hit and run cases. So there are accidents, people drive very bad, they crash, and instead of waiting for the police, they just run away. And then forensic scientists need to jump in. And with Raman spectroscopy, you can actually identify from the scrapes of paint the specific vehicular build or model from which, or in many cases, the formulation of the paint, which usually is very proprietary and changes from company to company. You can identify which kind of automobile it might have been which has stuck or participated in the accident. And it's important to remember that to do this kind of analysis, especially for vehicular accidents in India, there's not, as far as I know, there's not any centralized database or any kind of service which can be offered to the law enforcement. And that's something it's worthy enough to look into, because it's not very difficult to build a database, because you have access to a Raman spectrometer and you have access to vehicular paints. So you can just make reconstructions and actually create a database where you can offer services to the law enforcement to just acquire a um, non-destructive analysis of acquiring the spectrum of the vehicular paint and comparing it with your database. And you can actually give a lot of precious information to the police, because with that information, it can really help them save time and narrow down the search. Okay, now the very, very famous question in forensics, and not very famous question of archaeology, is who? Is the identification of individuals, is the act of determining who someone or what something is. But we'll focus on people first, let's say. So in archaeology, this is a very recent study. It just came out 2 or 3 months ago. It's from the Indus Valley civilization, which I'm sure all of you have heard of, is very famous. And they had discovered some skeletons from the burials, which had been recently excavated. And the researchers were very curious to know how these people from the Indus Valley looked, because there is this whole debate of Aryans, Dravidians, European tribes coming into India, natives, locals, non-locals. It's a very interesting study. If anybody is interested I can send the publication to the organizers to be distributed. And so what did they do? They did the same thing which forensic science has done. They did a facial reconstruction, and you can actually see the computed models and the final versions of how they guess that these people might have looked. And it's very surprising because, at least in terms of archaeology, because these people don't look anything like many of the statues which had been, or stone busts which had been recovered from the Indus Valley. So now it has sparked off another debate. But yeah, this is facial reconstruction, something which is very common in forensic science as well. You use facial reconstruction to uh, to create a reconstruction of how the person might have looked, usually in case of unidentified remains. So you have the original skull, you take measurements for different features, then you do the clay sculpture or put the muscles and the skin. In the olden days, they used to do this manually. So this was something which required great deal of skill and experience. But nowadays you have computer algorithms and softwares to do this. And then there were also sketches in some cases. And then they would try to match the reconstructions with missing people, or send these reconstructions out for people to actually recognize them. Now, the thing is, you might ask, oh, but how can we get into something like this? This is something which the police have been doing for a long time. We don't know. We have made vast improvements in terms of computation and informatics. And I would suggest that you invest your time more towards AI and machine learning, because maybe making automated recognition of people with just surveillance cameras and then trying to match it with the database. This is the kind of things which are very trendy at the moment in research and also security applications. So it's a direction which forensic science in India can actually take. And another case from archaeology is DNA studies. It's very weird how we apply DNA studies for human dispersal um, across the globe, because we all, our ancestors all evolved in Africa, but from there they actually moved out in different waves and we actually colonized the entire planet. But how do we know? But we all look different. We all eat different. How do we know that we are all the same or the different? And when did we split off? How far in the family have we split off? DNA is actually a very helpful tool to identify human dispersals across the globe. And on the screen, you can see how we actually started off in Africa and actually colonized the entire world, including Australia and all those tiny islands in the middle of the Pacific Ocean. And you can see that it had started somewhere roughly around 200,000 years ago. And in the Indian system, that would be 2 lakh years ago. And in a completely different approach, forensics use this to identify victims or criminals. And I'll not speak anything more on this, because I'm sure you guys know more than me about how DNA analysis is done to identify both victims and criminals. So the next question is when? Chronology. This is very important for crime reconstruction as well as in archaeology, because you need to understand what time period are you talking about when you talk about a specific site or archaeological context. So chronology is the arrangement of events or dates in the order of their occurrence. So in archaeology, we date the events or the artifacts using radiocarbon dating, but there are also other kinds of dating. There is the uranium lead dating, uranium thorium dating. It depends on the time period you're talking about. Up to from the present to 50,000 years ago, we can use radiocarbon dating to accurately put an event or an artifact in time. So what happens is all living beings have made of carbon, because we are made of we are carbon based life forms. And because of the bombardment of cosmic particles, there is certain amount of radioactive C14 isotope which forms apart from the C12 and the C13. When the organism is still alive, this C14 is continuously replenished. But once the organism is dead, it stops making any new C14 because it's dead, and the C14 continuously decays in a first order rate reaction, and we use this to build a calibration curve, and we measure how much of the C14 is left in the artifact to determine when the organism had died, and that would roughly be the time period from which the organism had actually been in time. What do you do in forensics? A very good and very famous and a very controversial example would be the estimation of the probable time of death. So you have different rule of the thumb observational methods, livor mortis, rigor mortis. Then you also have the temperature, body temperature, which you actually take it either rectally or in the abdomen, and you use it to plot it on a calibration curve. And it's very controversial because it is completely dependent on how the person was dressed when the person died, what was the ambient temperature, was the temperature fluctuating. All these things have to be considered, and many people have put forth many kinds of proposals, but none of them have been actually completely accepted by the international law enforcement and the forensic community. This is something very interesting, and this is something which people always want to know, which is the time of death. And people have actually started taking proteomics and some quantum dot approaches from University of Peking in China a couple of years ago, and they've also tried to take a colorimetric approach to measure the change in colors of the blood and the muscles. It's very interesting to look into this, and many of these investigations do not require plenty of economic support, and is something which can be taken up pretty much by small research groups, primarily consisting of students. So why, the famous question of forensics, why, and this is what they always keep asking in the court, to know the motive, and motive is a reason for doing something. So how do we use natural sciences to understand why? Well, in archaeology, the why is always open to reasonable and subjective interpretation after answering all the questions from before, because natural sciences cannot answer the question why in this sense of reconstruction of events. You need to take a look at all the evidences in front of you, and you need to put them in a frame in which they make sense. So how do we deal with this in forensics? It's the same in forensic science as well. Whatever crime reconstruction you have done is always open to reasonable and subjective interpretation, more or less depending on how the evidences fit. But usually, if you have a good fitting of the evidences and in the circumstances you're talking about, you arrive at the most probable occurrence of sequence of events, which is your reconstruction, basically. And the last question is how, and how answers the question of process. So a series of actions or steps taken in order to achieve a particular goal. And how do we explain process? In archaeology, we put all the facts and then come up with a plausible explanation. Because how are you going to answer how if you don't get all the facts? And the facts are given by the application of natural sciences on the material you find, but the natural sciences themselves do not answer for this how. And what happens in forensic science? We have a very fancy Latin word in forensics, which is modus operandi. Is a word which I like very much, but unfortunately they don't use this word a lot in archaeology. So this word basically means that, like, what's the method of operation? So you just try to understand or come up with a very plausible and reasonable modus operandi for how the crime has been committed. So we end with case studies with those questions, and I hope you took something from how there can be lateral transitions from allied fields to forensic sciences. So let's take a look at this outlook. What's this outlook? So we are talking about, when we mean outlook, we mean perspective. And you keep seeing all these inspirational quotes on social media and internet these days. It's that perspective is all about how you look at things. And when I meant outlook, it was not. It's about how you look at it, obviously. But in my case, I want to really push this point home to all the people who are pursuing forensic science, that it's not how it looks at you. It is not about how the field of forensic science feels to you at the moment. It's quite bigger and it's quite different from how you're perceiving it. And I hope to change your perspective with this. Excuse me, something has happened. Okay, sorry. Um, so I would like to present to you a brief list of key factors to keep in mind when you're developing your perspective about forensic science. So the first thing I would like you to keep in mind is your attitude towards forensic science. And we should not at all pay any attention to what attitude does the field of forensic science has towards you, because that is not vital for your success in the field and your efforts to advance the field in our country. So the first one is to have a proactive approach towards the field and actively chart the trajectory of your career. What is proactive approach? Proactive approach is you don't sit for opportunities to come and be offered to you. You go out and you look for your own opportunities in the world, or if there are no opportunities, you create an opportunity for you. You have to be resourceful and you have to be very flexible in your approach. So when you are both proactive and flexible, you end up actually creating your own trajectory for your career. And please remember that your trajectory need not be the same as the other successful people around you. Sometimes that's not the best trajectory you can have. So it's vital that these trajectories are very personalized to the individuals. And I'm saying this because just because I had success for transitioning from forensic science to archaeology does not mean the next person who would transition from forensic science to archaeology would actually be successful. The second one is shedding the age-old thinking of landing a very comfortable government job in the FSL is the only option you have as a forensic scientist. And this is, I have no words to explain how much this approach is detrimental to both thinking and having a very conducive environment around you. Because as long as you rely of this thought of that a forensic scientist can only work in an FSL as a scientist, there cannot be progress and there will not be success as well, because forensic science as a field is not actively pushed forward by the governmental policies at the time. And we as researchers or as scientists, as students, do not possess enough leverage over the government to actually change its approach towards this at the moment. But that does not mean that we should sit idle and wait for them to change the policies. We should actually start thinking of creative ways to actually make ourselves commercial and to sell ourselves and our ideas as a product. And the last one is very, very important if you want to stay in forensic science, is that you need to have perseverance. Perseverance is being very stubborn, but in a very clever way and in the right way. Because if you want to achieve your career goals, it's never going to be simple, neither in forensic science nor in any other field out there. So, especially when we are in a field like forensic science, which is an applied science and is a science which is dependent on the governmental policies, more or less, if not completely, we need to persevere. We need to sometimes just wait out some bad time and in the meantime prepare for the better times, so that when time comes, you're prepared and you're ready to seize any opportunity which passes by you. So, this is about attitude. Now, sorry, let me just move this because, okay. Um, so the next one is about networking. And networking, I cannot emphasize this enough. You cannot be successful in any field if you do not network, because you need to constantly collaborate with other people working alongside you to do greater things, because the strength of a team is always greater than the strength of an individual. And for the journey ahead in forensics, it's essential that you develop a very strong professional network with having working groups dedicated to different fields or applications. And I say this from my experience that as a researcher now in a field, the most important thing for me, if I am successful or if I'm a failure, is dependent on my network, is about who I know. What I know is very important because that's the quality which I have. But who I know is way more important, because knowing the right people actually makes all the difference if you're successful or not. But by knowing the right people, I don't mean anything illegal or corrupt or nepotic. I mean knowing the right kind of people you need to connect to actually go from your ideas, your aspirations, to actual applications and real and success in the real world, in the market. Yeah, research, knowledge, and industry. We have been talking about research, we have been talking about ideas. So yeah, it is very important to actively engage in research and work towards developing new techniques and applications. And we talked about multidisciplinary, interdisciplinary, and transdisciplinary, and here is where it comes back again. Forensic science requires a problem-based solution development, which is a transdisciplinary approach. You look at the problems first, you look at problems which are there in the real world, and then you go solving them. And this is a very qualitative leap which needs to be taken. But it's not necessary for everybody to engage in research. Research is not everybody's cup of tea. Not everybody needs to do it, and not everybody is actually skilled or capable enough to do it. Some of you might be interested in working in the industry, and that's perfectly fine, and that's perfectly important. But not all of you jump on the same bandwagon. And it's vital for individuals in both research and industry to collaborate. And this is the networking I was talking about before, because you need to bank on each other's knowledge base, because the industry tells you what it needs and how it needs, and the research looks at their problems and comes up with innovative solutions. And commercialization. How do you commercialize something like forensic science? The first thing you think of is everything is in government's hands, the laws, the the statutes, the organizations where you can work for. But this is not true. Having a problem-based solution development means every solution has a potential to be commercialized, because the application, the technology, the know-how, it could become a patent, it could become a software, it could become a service, it could become a product which you can sell back to the government. And if your product is actually good enough to be sold on the market, you actually have something very, very vital on your hands. And it's not something which the government can control. And how do you do this? How do you know what problems does the government or the bodies of the government which deal uh, with security, with law enforcement and judicial systems have? You need to work very close with these people. How do you work close with these people? You need to find ways. You need to find a way where you make yourself transdisciplinary, which means you cannot be an individual only from forensic science. You need to be more. You need to find other fields where you can move into, where you can transition into, at the same time not forgetting, not leaving your roots in forensic science, and you make it into a transdisciplinary approach. And this will help you gain a very holistic understanding of the various shortcomings in the system. And I can give you a very good example. We have a very huge growth in security threats in the world, both digital and physical. And forensic sciences have taken a new role of prevention and investigation with cutting edge technologies. And there's a huge market for military, security, intelligence, and economic applications where people with forensic science can really contribute a lot. And we don't just contribute with our knowledge, we also contribute with our perspective of looking at the world. Because for forensic science, everything is something which needs to be investigated, something which needs to be looked very critically. And it's not easy to find people who have been trained with this kind of perspective from an undergrad. So you need to find a way to attach yourselves to other disciplines as well, and also commercialize your ideas. And I would like to point out something very interesting here. In the beginning, we have spoken about pure sciences, applied sciences, and then we said that there are people whom we call engineers who look at how we can transition from theory to application, and they're very problem oriented solution seekers. And when I looked at the full form of CRAFTS, and you called it the Council for Research Applied to Forensic Technology and Science, I think I can confidently say that this is already a right step in the right direction, because you have not just said forensic science and stopped, which means you're actually looking to solve problems which are there in the real world. And when you put the word technology there, it means you're actually going to start developing solutions to problems. And every solution for a real world problem has a potential to be commercialized. You just need to find the right way and the right time to do it. So, closing remarks. Forensic science is just the beginning of your career. You cannot stop with forensic science and expect to succeed in the modern world. It's just the beginning, it's just your first step, and you need to go and progress into other disciplines and other ways of thinking. And it's only the central circle. You need to add other circles to become transdisciplinary. So you cannot have just one circle and say, oh, but I'm a forensic scientist, I've been multidisciplinary, interdisciplinary. No, you need to be transdisciplinary. And forensic science is just one circle. Doesn't matter if you study physics, biology, chemistry, computers, psychology, or anything more. You need to add other disciplines. You study all this just to build a base in pure forensics. This is not transdisciplinary. Transdisciplinary comes when you go out and start adding another degree in law, another degree in cybersecurity, another degree in analytical chemistry. That's when you just start being transdisciplinary. But remember, forcefully adding these disciplines into your resume will not make you transdisciplinary. You need to first find the problems you want to solve in the world. And only then should you go looking for which discipline do you need to add in your CV, which discipline do you need to skills do you need to add into your skill set for you to solve the problem. Only then will you be successful. Only then will you be commercial. Only then will your idea have a potential to be commercialized. And forensic science is just one color. So the final color depends on how and what you mix into it. So that's all I have to say. Thank you.
Thank you so much, sir, for such a inestimable information and the motivation you have given. So, sir, we have some queries from our attendees.
Sure.
Yeah. The first one is, according to the continental drift theory, land was once a single part, but there was a shift in position of continents on Earth's surface. So, can isotope be used to find out the exact connections between the continents?
Yeah, okay. So this is a very broad question, but I'll try to explain. So when you mean isotopes, I presume they're talking about stable isotopes, because there are also the radioactive ones, and the application of radioactive isotopes is very different. So I presume they're talking about stable isotopes. So carbon, nitrogen, oxygen, and sulfur are the main ones which you use to investigate flows of energy through the food webs or food chains. And this is completely dependent on photosynthesis, fractionation processes of the enzymes within the living beings. So these are not really dependent on where you come from, geography or geology. But of course, I've shown you an application of how we use this fact that there is a fractionation of isotopes because of biological processes, how you can use that to identify geographically. But remember, you cannot identify using these values for the whole planet at the same time. You need to know what context you're applying it. And the other stable isotope, which is mainly used for provenance, and I recommend you can go and look for articles and you'll find a lot of them, are strontium isotopes. And these are also heavily applied for forensic science to identify if you have an unknown body, to identify if the person is local or non-local. Because along with calcium, our body uptakes strontium and stores it in our bone. But the thing is, for teeth, which have the same process, once the enamel forms, it's a dead tissue. It does not reform again and again. So if you actually can access the third molar of an individual, you can see the strontium isotope signal of that person when the third molar formed. And usually for an adult, it forms in when the person is an adult. And with that isotope value, you can tell if the person is actually a local or a non-local from the place where you found the body. But that's all you can say, is if it's local or non-local. But non-local could be another geological formation which is still close by but not geologically the same as the place the body was found. Or in some cases, if it's well studied, the strontium isotope geology of the region, you can more or less place where the person could be from. And of course, then you follow it up with other techniques. So yeah, the land drift and the isotopes are not really related, but yes, the strontium isotopes are dependent on the geological formations.
Thank you, sir. So the next question is, what are the areas in archaeology that can be considered as emerging areas for future research?
Oh, that's a very interesting question. So, archaeology is also becoming transdisciplinary, at least in here in Europe. That's where the direction is, and I don't think it's going to happen like tomorrow. It's going to take a couple of years or at least one generation of people to completely make the leap. But I would say the emerging area would be proteomics. But again, when you say transdisciplinary, these emerging areas completely, the question negates itself, because you don't talk about areas anymore, you talk about problems. But if you really want me to point it out, I would say people are moving more towards proteomics and molecular based investigations like DNA. Nothing new for forensic science either, but it's just the application level and the technology which has improved.
Thank you, sir, once again. So one more question. Can we facially reconstruct a damaged skull?
Uh, I must actually refrain from answering this because I'm not an expert on it.
Okay, sir. The another one is, how can archaeologists assist a forensic scientist in crime investigation?
That's actually a very good question. I think you actually have books of forensic archaeology in the GIFSA library, and I would recommend people take a look at that because you would actually get an in-depth review. But when you actually find bodies which are buried, forensic scientists or even law enforcement for that matter of fact are not used to digging stratigraphically, which is you take out one layer of earth at a time and you're very careful while taking it out. So it's actually a complete different skill set which you need to develop over years to also have the kind of eye to identify how the color of the soil is changing, what time of the day is it the best to actually excavate, and to excavate in a specific way. So it's actually a complete different skill set, and it's very useful to have an archaeologist with you when you're actually when you actually find bodies which have been buried.
Thank you, sir. Sir, and most of our students, they are so curious how to get this research fellowship, the one which you're going through.
Okay, so that's what I told you before. For the masters, I don't know. You apply. I don't know the criteria at which they take, but that's what I told you. If you want to transition into archaeology, it does not necessarily mean you will be successful, because I could make it till here, and I don't consider myself successful yet because I'm just doing my PhD. My success you would know most probably after 10 years, by the time which all of you would have already transitioned into archaeology if you did. But I could actually recommend you to the viewers and to you people. There is another masters of it's an Erasmus Mundus masters for security, intelligence, and economics. And I think that's more in tune with forensic science, because they actually talk about counterintelligence, economic offenses, terrorism, and that's an application into security. And I think it's better if you transition into an allied field. That does not mean you shouldn't transition into archaeology, but I'm just saying that don't look one dimensionally. Just because somebody before you has succeeded does not mean it's the best solution for you guys. But I'll give you a bit more of information. I had actually written to the people from that consortium. They were very much interested in people from forensic science, but they also wanted people from like us, basically with the same qualifications as me, because all of you would have the same one if you were exiting from GIFSA, to actually have at least another study in either law or history or some kind of sociological sciences, in keeping in perspective their kind of program. So that's why I said forensic science is just the first step. You cannot stop there. You cannot completely transition into something else with just forensic science there with you. You're not specialized enough for problems.
Thank you, sir. Sir, and one friend of mine is asking, how did you find your interest in archaeology after forensics?
Oh, that's the deal. I'm not an archaeologist. I'm an archaeological scientist. So I just do chemistry, which was what I was doing in same as forensic science. And my interest primarily lied with bones, teeth, and a bit of interface between biology and chemistry. And I just continued to do the same. So I just changed context from a more modern skeletal remains to skeletal remains which are from thousands of years ago. Yeah, it's just a matter of how flexible you are and how what your interests lie with. I was lucky enough that my interests could be applied in both the fields, or else I was planning to do law. So
Thank you, sir. Anyone more interested to ask some questions? So one more question. Can we
yeah,
identify DNA from bones buried 2000 or 3000 years back? Yes.
they've actually sequenced individuals as old as 200,000 years ago, 2 lakh years ago. So 2000, 1000 is not really that of a problem, but the extraction protocols are slightly different than the ones which we do for normal forensics, because it needs to be more sensitive for extraction, but not necessarily that in all the cases you'll be able to extract it, because it again depends on the preservation conditions.
Yeah. Thank you, sir.
Yeah.
So one question,
Yes.
how does forensic archaeology work within criminal justice system?
Okay. At least in the Western world, very well, especially in countries like UK, it works very well. Like they take them, but I'm not sure of how it would work in India. That's the problem. When you talk about criminal justice system, it really varies from country to country. It's completely political. It's completely what people think is acceptable or not. It's completely about how people want the process to work. For example, in India, you know how it is. They doesn't even exist because it's not a thing yet. And for example, in the UK, it's really big thing. Many people do these masters where they do forensic archaeology, but it's not a trend in continental Europe. There are countries which are neighbors to each other, but it's not a trend in continental Europe for you to find a forensic archaeologist. Archaeologists simply don't train in forensics here. They might collaborate. They might be called as experts to work with the law enforcement, but there is no such thing. Whereas it is a thing in the UK. So it's completely dependent on the legal system.
Okay, sir. Thank you, sir.
Yeah.
So there are no more questions now. They're satisfied with your answers.
Okay.
So as there are no more questions, let me conclude this session. GIFSA Crafts team is thankful to you, sir, for giving us time from your busy schedule and enlightening us with your immense informative talk. I also thank Director Sir of Government Institute of Forensic Science, Aurangabad, for his valuable guidance and support. I also thank Dr. Rajesh Kumar Sir for this initiative, guidance and support. I also thank Head of Department, teachers, staff members, students for being with us in every part of this initiative. And last but not the least, thank you everyone for attending this session and hope to see you soon again. Also, I would like to make a note. If any organization wish to collaborate with us, then surely GIFSA Crafts will welcome you. Thank you.
Thank you.
And yes, the certificates will be given through our Telegram channel. So do follow it. Thank you so much, sir, for being with us.
Thank you.